All right, today is the day, and this is a little bit of a milestone day. In fact, we have here the first part for the body of the Arete project. We started pulling molds off of the car. They're coming off, and since I pulled these front lower quarter panels off, I thought I would go ahead and start laying parts up. Our first part here, this quarter panel weighs in at just about 1.5 pounds. So I think I've achieved the ratio that I want for the stiffness I need and the weight we're after. Anyway, this video is going to take us through the process of building one of these parts and maybe show you a little bit about pulling the molds as we start to do that. Anyway, let's go take a look at that. Okay, if you noticed making of these molds that all the edges are a little bit frayed and jagged, so we're going to go ahead and clean those up. Taking a die grinder, cutoff disc, go around and trim off all the extra frayed fiberglass, just clean it up a bit so that we have nice edges that aren't going to be snagging us and giving us slivers in the end. I just take the dust extractor and keep that with me to pull off all the dust as we go. The two flanges from the two separate molds can all be cut together. On the back there'll be a place where we will actually drill holes for bolting the pieces together, but here there's not any connections. And if you remember these metal flashings under the wheel wells and under the front lip, those just take the screws out, those pull free. Once we have the flashings and the trimming all done, it's time to start trying to remove the parts. I have a little tool. These are good tools you can pick up at Harbor Freight. You don't need any quality in this. You just need some plastic or nylon wedges. A little nylon chisel here as well. Trying to get me a gap underneath this lower quarter panel. Once I get any space, then it's a matter of just inserting these nylon wedges. Those wedges start putting pressure on the part to push it away from the plug. There it is, popped right off. Of course, that small piece doesn't have a lot of adhesion, so now the trick is going to this large hood bonnet piece. Get those wedges in there. They just continually add pressure to the surface that's still bonded. Once you get the wedges in, you can actually walk away and let that put the pressure on and start keeping those parts peeling away from each other. I'm just going back and forth, side to side. I'm working all the edges that I can find that are coming loose. You see there of the wheel well there, that's coming nice and loose. Keep working the edges. Of course, now the only place it's bonded is in the center where we can't really get to it without a little pressure coming from every side. And there it's finally breaking loose. And we have the biggest mold off. Now this part weighs just a little bit more than the actual hood will, but that's... And once that thing's off, it is ready to be cleaned up, polished, ready to take parts out of. Now, remember, we've been talking a lot about how this mold had to come off because we need to cut this section out of the plug, because the dashboard will actually be part of another mold system, but that is underneath this part of the hood. So before we go on to making our part, we're going to just show you here cutting away this section of the plug, getting ready to take the mold off of the center section of the tub. Get a die grinder with a disc in it, just cuts that plaster. Then I had to take a Stanley knife, go in and cut the burlap, if you remember in there, that burlap. Main strength of our plug in the plaster. Cut those pieces out, get them out of the way. And there they are. Got all those pieces out. We'll be prepping that dashboard area for taking a mold off of. Okay, time to build a part. So now you're going to understand why the flashings and why we built the molds with the flashings in reverse. The original flashings we made out of clay, we built our mold up against it, now are sticking out of the mold, and we have to put on these little metal flashings to create the turn back into our part. If we'd been able to create these turnbacks, we would have had to mold each part of the car separately. And to do that, of course, would have taken some sophisticated CNC machine and an extremely expensive process, because it's not just a matter of machining foam, but machining foam and then putting a hard surface on that foam and machining it again. So we're going to go through this process, and you'll see how this whole flashing creates that internal flange. And as we get into the doors, we'll be able to create that internal flange with a couple of sophisticated turns in it. Now we have our flange all set up, our mold release ready. We put in our first layer of cloth. This is a 3-ounce satin weaved. We want a real fine weave so that the print through doesn't come. We're also going to put in a pretty heavy layer of epoxy, because we want some of that epoxy to pool against the surface of the mold to create our finished surface. We want enough epoxy there that if we have to do any sanding or any finishing, that we won't be breaking into our fibers, at least not too early. So saturate that first layer pretty heavily. Like I said, this is an E-glass, this satin weave. It's hard to find a satin weave in the S-glass, but we're just after the surface created by that satin. So once that is impregnated very well, it's time to add the structural part of this piece, which is the S-glass. S-glass being, of course, much stronger. We're just going to build up as many layers as we need to achieve the thickness and the strength that we're after in this part. Again, more S-glass going into the corners to build up those flanges. And once that is built up to what we want, we're going to let that cure. Because with the surface we want to be hard as we put our Nomex honeycomb against it. So after this reinforcement is done on these first few layers to make our surface up, we're going to let it cure and then come back and put a layer of resin on. That layer of resin is to bond the Nomex, the honeycomb, to those first few layers. Now this honeycomb conforms the curve really well. Sometimes if there's a little bit of a gap though, you want to vacuum bag it. Of course, it's the preferred method, but here I'm just going to put some weights on. I had a bunch of sockets, of course, easy to just drop them on there to push the honeycomb down into any little pockets that might be underneath there, because we want the entire surface bonded well to that first layer. And there it is. You see the edges are beveled. We want that so that the air pockets won't form around the edge of the honeycomb, and this next layer of satin weave is going to go back up against the honeycomb. It'll be the layer that bonds to the backside. Again, using a satin weave because it conforms so well to these surfaces. It's a matter of saturating it. Of course, you have to be careful not to do too much resin on the honeycomb, or it will just fill the cells. Just enough to impregnate the surface of the cloth and bond it to the honeycomb. And I've missed a step here. You didn't see me add some more reinforcement there, but that was reinforced on top of that satin layer. And now we're just stripping the mold down, taking the clamps off. That little metal flashing all just comes off, and now you can see the turn back that was created. Go ahead and finish stripping this whole thing down. Don't we wish we could really actually work this fast, huh? Then same thing we did with pulling molds off the plug. This is pulling the parts out of the molds. Little plastic wedges. Find a gap, start driving them in. Work your way around, just put some pressure to force the separation of those two pieces, and there it is. We have our first part out of the mold. Okay, so we got the first parts off the car, and it's good to have these small little pieces to work on to arrive at what we want to accomplish. Actually, the first part that I pulled off is this piece here, weighing in a little closer at 2 pounds, was a little bit heavier than I wanted. So how do you actually get to what you want it to be? Well, sometimes it is a little bit of trial and error. Of course, a knowledge of knowing what materials are going to combine helps. We certainly don't have a system of finite element analysis for composites we're going to be using on this project. But we do have something that we have, and that's a little bit of experience in knowing how heavy a part needs to be to achieve the stiffness. So the best way to arrive at that is to put some layers together and find out what you have, how much resin is going to be applied to those layers, and what their weight will come out. So this is a sample that I put together right before making these parts to come to the conclusion of what I need. And I'll be doing a little bit of I think I'm going to do a little composite series to kind of show what the strength of materials is when you do a combination of layers. So these are some samples from that, like single layers. What's the stiffness you arrive at when you add a combination of the same material into multiple layers, and a combination of different weights of fiberglass or other fabric cloths, and what the stiffness and the strength you arrive at is by combining those things. Anyway, that's going to be another video that I'm going to apply to a new series that I think I'll be doing completely into the FRP department. So hope you come back and see those as well. But thanks for watching this video, and glad to have you along.